All right, let's start. Matrix notation. So the elements, that's the formal name for the numbers in a matrix, they can be located or specified by their row and column, much like you do with a Cartesian plane. When you state the coordinates on a Cartesian plane, what do? You put the x first, you put the y after. So if we consider the matrix, matrices are identified by a capital letter. So if we were thinking about matrix capital A, which has the order m times by n, the information tells you that A is going to have m rows in it and n columns in it. So the first notes that you should take, for the people that haven't been in my class, anything in blue is what I think you should write down. I can't force you though. And purple is the worked examples. Anything in red is just like a little note there. There are no exercises for this little section. So you should have this on your cheat sheet only. If I want to locate any element in matrix A, I do that by having square brackets, small a, and then two numbers, I and j. And I close the brackets. Why is it small a? Because the small a tells you we're looking in matrix A, but because it's small, it's telling me that I'm looking for the number within it. If I wrote capital A here, that means I'm looking for the actual full matrix, okay? So if I have in little brackets small a, that means we are looking for a number in matrix capital A. And then the numbers beside that small a, I is going to be the row that we're talking about, and j is the column. I'll give you some time to get that first little bit there, and then we'll do the example. There's one question worth 2 marks in your test. It's a small test, so 2 marks is worth quite a bit. Try not to lose those 2 marks. Some time to get the example as well, and I'll talk you through the example. So little brackets here, small a, which means we're talking about an element in matrix capital A, and it says 5, 6. 1, 2, 3, 4, 5 down. 6 across, 1, 2, 3, 4, 5, 6. So if you are asked a question like that, element A, 5, 6 is going to be 7. That is all that is. There's no practice exercises for that. Check that on your cheat sheet. I'll scroll down so people can get the next bit. Next bit, two matrices are considered equal if they have the same order. What does that mean? They're the same shape. Same number of rows and columns. The elements in matching positions have to be equal. So all the numbers have to be the same and in the same place. It's kind of self-explanatory, but it has to look the same, okay? So hopefully you don't lose marks in a question like this. Example, state whether the matrices below are equal. If not, then create a matrix equal to matrix A. Are matrices A and B equal? A and B are not equal. Let's make a matrix C. What numbers do I need to chuck into the first row of C to make it equal to A? Say it louder. And then second row. Done. There's no trick to that. That's literally this topic, okay? That's it. What do you reckon a zero matrix is? Yeah, that's a thing. I have to explain that to you later. Get that down just in case. If you feel like you can remember it, I don't think you should need cheat sheet space for this. But if you do, no judgment. Okay? C is equal to a I'm going to scroll down. I'm going to listen for annoyed moans. No. Oh. What was that? That wasn't a moan. That was like a... I'm not allowed to say that. Matrix addition and subtraction. You can only add or subtract matrices that have the same order. They have to be the same shape, or you can't add or take them away from each other. To add or subtract matrices, you simply add or subtract elements that are in matching positions in both matrices. Once all the corresponding elements have been added or subtracted, the result must have the same order. So if you add two things that are the same shape, or subtract two things that are the same shape, the answer should also be the same shape. So what I'd like you to do, please, is get what you can of adding and subtracting. And the first part of the example, because we're going to subtract these matrices, A, B, and C. You'll notice I've marked some of the DIs already, but they're the ones that needed it for their report or needed it to pass. Everyone else, I'll just be randomly. I might alternate. Easy one, hard one, easy one. Mental health. I'll be slower than normal because I've got a 30 student Ignite class that I'm marking something for as well. Still not months. Maybe like a week or something. Oh my God, that's forever. That's ages. Bro, I marked your stats tests in 2 hours. I'm just being generous. Just being a bit humble. Tests shouldn't take that long to mark, bro. You should know what the answers are. Matrix addition and subtraction. Let us add. Oh, okay. Jesus. Let's see. Let's try again. All right, let's try adding A and B. This is laborious working out, okay? But I suggest that you work it out like I am, so you don't... Because if you trust yourself to remember these and you mess up a number and your answer's wrong, you lose everything, okay? Whereas if I show my working out that I'm adding 1, 2, 3, 4, 5, 6 to 2, 1, 6, 0, 3, 5, then at least if I saw that you accidentally miswrote something there, then that's the only mistake, right? But if all you gave me is the wrong answer, well, you're not going to get anything for that. So are these matrices the same shape? Are they the same order? So therefore I can do it. And because it's addition, I just need to add the numbers that are in the same place. So 1 plus, what am I going to add? 1 plus 2 will be 3. So let's go across. 2 plus 1, 3. 3 plus 6, 9. 4 plus nothing, 4. 5 plus 3, 8. 6 plus 5, 11. That's it. A plus C. Are they the same order? So you immediately say cannot be done. Why can't it be done? They're not the same shape. There's nothing for me to add 3 to in C. Not the same shape, cannot be done. Then lastly, B take A. So write out your working. 2, 1, 6, 0, 3, 5. Take away 1, 2, 3, 4, 5, 6. You guys get access to a calculator. In previous years, I haven't taught it for a while, but when I was teaching it, they weren't allowed notes or calculator for this test. So a lot of people struggle with subtraction, but because you'll have a calculator, just use the calculator for subtraction. Don't trust yourself for that because there's not many marks in this test. So 2 minus 1 would be? See how everyone... That was a slow reaction. Because you have to remember negatives. So this is what... Because I didn't teach you at year 8, okay? I wouldn't have hammered you with... As soon as you are minusing numbers, you need to imagine a number line. And the negative numbers are on the left and the positive numbers are on the right. Shh. Why is that important? Because right now I'm doing 1, so I'm here. 1 take away 2. So what direction am I going to jump? To the left. 1, 2. So I'm going to be at negative 1. For that, 6 take 3. 0 take 4. Negative 4. You've in a sweat. 3 take 5. Oh, okay. We got a badass over here. 5 take 6. Someone said 1. Negative 1. You can use a calculator. Use it in your practice. You will have access to a calculator for the test. Can someone tell me, because this will be relevant in your exercises, does the order of addition matter? No. So there's going to be some questions in your exercises where it says, is A plus B the same as B plus A? Yes. I can prove that to you because what's 1 plus 2 plus 3? What's the answer going to be? 6. What's 3 plus 1 plus 2 going to be? 6. But does the order of subtraction matter? 5 take 2 is? What's 2 take 5? See how they're different? So that might be applicable to your exercise. The only other thing that I need to cover, a zero matrix is simply a matrix where all the elements are 0. It seems obvious, but apparently it's a term you need to know about. So here you go. If I wanted to do a zero matrix with order 3 by 2, although that order thing's tricky, how many rows is that going to have? 3. So it's going to be kind of tall. 3 by 2, it would be 0, 0, 0, 0, 0, 0, like that. That is it for today. Your homework and now exercise 14b.1. Oh,